This video is going to cover the topic of algebraic equation solving. Be sure the date and topic are at the top of the page. The essential question for the video is, beyond backtracking, how do we solve algebraic equations? So in the past, most of us have used backtracking to solve algebraic equations, and it looks like this. We would start with an equation such as 2x plus 6 equals 12. And we'd fill in our boxes. So we'd say we're starting with x. We know that we are multiplying it times 2. Then we are adding 6. And we know the total is 12, right? And then we would backtrack. So we would say let's subtract 6. And then let's do the opposite here and divide by 2. And 6 divided by 2 would tell us that x equals 3, right? And this is a great system. And it's great when we're first learning about solving for x and learning about solving for variables, but it is limited, and as we progress in math and problem solving, we need more options. So today we're going to look at the next step in algebraic equation solving, but let's make sure we have a few reminders. The first reminder is that an equal sign in an equation doesn't just mean that it's the answer to the problem, but it means that the values of both sides are equivalent. They are the same. So that's going to be an important thing to remember. Also, when we were working with backtracking, we talked a lot about undoing operations in the opposite order in which they are applied. This is called using the inverse operations. So the inverse of adding is subtracting, for example. And lastly, our end goal whenever we're solving algebraic equations is that we want to isolate the variable. That means we want to find the value of the variable, and the last step will say something like x equals blank, right? So x is all by itself, all alone on one side of the equation. So we're going to talk about our new method side by side with backtracking as we learn to transition. And I'm going to just use the same example that I had at the start of the video. So here on the left, you can see that I've set up my backtracking, and I have 2x plus 6 equals 12. And I've recorded x. I know that I'm multiplying by 2. I'm adding 6, and that gets me a total of 12. And on the other side, I'm just going to write the equation itself. In the backtracking method, the first thing I would do would be to do the inverse, right, the opposite of the final step. So since our last step was adding 6, we would first subtract 6, and we'd say we'd have 6 in that box, right? That's what we've done in the past. On the other side here, to kind of mirror what it is, well, I know that we just subtracted 6 from 12. So I'm going to write 12 minus 6 equals 6. However, remember we have our equal sign here, so that means that both sides of the equation must remain the same value. And if I only subtract 6 from the 12, they're not the same value. So I also need to subtract 6 from my left-hand side. So I'm going to write minus 6 on this side. But of course, if I subtract 6 by 6, I don't get anything, right? It equals 0. So on this side, these two cancel each other out, and I'm just left with my 2 x's. So my equation now just says 2x equals 6. Next in my backtracking, I would say, well, I also multiplied by 2. That was the next thing here. So I'm going to undo that by dividing by 2. And of course, 6 divided by 2 is 3, so x must be 3. Looking at my standard process that we're using here, I also want to divide 6 by 2, right? I want to do the same thing. So I'm going to go over here and I'm going to say, all right, let's divide 6 by 2. I'm using this as my division bar. And 6 divided by 2 is 3. But of course, I need to make sure that my two sides are remaining equivalent. So since I divided the right-hand side by 2, I also have to divide my left-hand side by 2. Right? And if I divide 2x by 2, I just get plain old x. Right? So there is x equals 3. Same answer. I've gotten to the point where x is isolated on one side, and I know therefore that x is the value of 3. But of course, we always want to check to make sure. So I'm just going to get back to my original equation. Let me just kind of narrow this off here. And if I think x is 3, then I'm going to go ahead and substitute in 3 for my x, and I'm just going to solve. And of course, if I do that, I get this PEMDAS. I would do 6, and then I would do my next step is also adding to make 12. And since I do know those two sides are equivalent, that means that is correct. 12 does equal 12, so my answer is, in fact, x equals 3. That did work. Let's do another one side by side. So I have 2x minus 8 equals 14, and I'm just going to set up the backtracking. So that would look something like this. And on the other side, I'm just going to write the equation as is. In the backtracking form, right, the last thing, my last step was that I was subtracting 8. So my first step would be to do the inverse, which would be to add 8, and that would be 22. And on the standard system, we're going to do the same thing, right? The last thing here was to subtract 8, so I'm going to add 8 to this side and also get 22. But if I do that, I have to make sure I'm keeping things balanced because both sides have to be equal. So I'm going to add 8 to the other side. And of course that means, well, negative 8 plus 8 makes 0. So I'm just going to end up with 2x. So I have 2 of these x's that equals 22. And coming back to the backtracking side, I know my next step would be to do the inverse of multiplying by 2. So I would divide by 2, and I would get 22 divided by 2 would leave me x equals 11. Right? That's what I would get. Back over on my standard form, I still want to do the same thing, right? I still want to do 22 divided by 2, and of course that still gets me 11. But over here, I have to do the same thing to keep it balanced. So I'm going to do 2x divided by 2, and 2 divided by 2 gets us 1 or just x, right? 1x or just x. So same answer. This way I don't have to draw all those boxes, and it's a little bit cleaner and a little bit easier to work with. But once again, right, I'm going to give myself a little space here. I want to see if my answer works. So I have 2x minus 8 equals 14, but I'm going to substitute in that I think x is 11. And I'll know I'm right if I get the same thing on both sides. They have to be equivalent. So when I do this order of operations, I get 22 minus 8. Hopefully that equals 14, and it does. So 14 equals 14. I know I've done it right. So my answer of x equals 11 is just great. As we move forward, we don't want to have to keep drawing the boxes for backtracking to kind of cue us into what we need to do, but we still want to think about the steps, and think about doing all of the opposite operations in the opposite order. So when I look at this, right, 3y plus 10 equals 19, I can kind of think about what it is that's going on here. So I know that my variable is y, and the first thing that happened to y was that we multiplied it by 3. Once y was multiplied by 3, we then added 10. So now when it comes time to solve, we're going to do everything in the reverse order. So instead of ending by adding 10, I'm going to start by subtracting 10. And once we have subtracted 10, I'm going to do the inverse of multiplying, which means I'm going to divide by 3. So let's go ahead and do that. Right? So the first thing I need to do to my 19 is I need to subtract 10. So I'm going to go ahead and subtract 10 here, which leaves me with 9. But if I only do that, my two sides are no longer equivalent. So I have to subtract 10 over here as well. And if I do that, 10 minus 10 is 0, and I'm left with 3y. So there I am, I've done my first step. Then I have to divide by 3. Right? So I'm going to take my 9 and I'm going to divide it by 3, which equals 3. And I'm just putting these long lines here to kind of separate each of my steps. However, if I divide 1/2 of my equation by 3, I better do it to the other side. Right? And 3 divided by 3 is 1, so I get 1y, which is just saying that y equals 3. And I did my division. Right? I did my things in the opposite order and did the inverse operations. So I think that y equals 3, right? That's what I'm coming up with, but I always want to kind of substitute it to check. So I'm going to do y, and I'm going to substitute that for 3. So 3 times 3 would be plus 10 equals 19. 3 times 3 is 9. plus 10 does in fact equal 19. So I know my equation works. I know my answer here was correct. And we're going to practice this in class so you can get more comfortable moving away from backtracking and moving to this more standard process. But the theory behind it, the idea behind it is the same. It's just a little less visual and a little bit more clinical, a little bit more operational. So be sure that you have your notes and any questions that you have about this. And remember that the essential question was that we were looking for a way beyond backtracking to solve algebraic equations. And hopefully you've kind of gotten a little glimpse into how we're going to start to do that.